Okay. Hello, everybody. My name is Genevieve Milliken, and I am the Data Services Librarian at the NYU Health Sciences Library. And I want to welcome you today to our workshop on Git and GitHub. As a note, this class is currently being recorded, and I will send out the recording and the slides to all attendees and all who registered later today once the video has rendered. With that said, I will be using a lot of sort of screens today, so I'm going to go ahead and turn off my camera just so I don't have to juggle that. But please feel free to ask any questions in the chat as we go through today's session. All right, I want to make sure that everyone has completed everything that was included in the pre-workshop instructions. And that means making sure that you have Git installed on your computer, making sure that you have a GitHub account if you already don't have one, and then adding an SSH key to your computer and then adding that to your GitHub profile. And then make sure that you have a text editor close by that you can open, as well as the terminal or Git bash. So terminal if you're on a Mac and Git bash if you are on Windows. So can I just get a show of hands? So if you can just use the thumbs up emoji to make sure that you have all of this and that you're ready to go. All right, I see a bunch of thumbs ups. All right. All right, so I saw a bunch of thumbs up. I did see one thumbs down. If you do have any problems, unfortunately, I don't have a TA to do any troubleshooting here, but you can go ahead and put the problems that you are having in the chat, and once we have a break, I can try to help you out. Otherwise, you are more than welcome to send me an email. This is being recorded, so once we get you set up with the SSH key, you can review the video as well. All right, so what we're going to cover today. So I will start out with a short lecture on what Git is and why we should use it. Then today's goal really is about working with syntax, doing some hands-on work with Git syntax in the command line. So that's where we're going to spend the majority of today. So we're going to go over how to use Git locally on your computer and then push to GitHub. So that means that our workflow is going to be local and then moving to GitHub. And then I will show you the reverse of that, of working in GitHub on a repository that's already there and then bringing it back to your local environment. But we'll go over some of the major Git commands. And if we have time, I will show you some additional ones, like how to see the difference between versions and how to delete and move files with Git. Okay, so a little bit of a caveat to start out, and that is to say that Git does not equal GitHub. So Git is a revision or version control system. Sometimes this is shortened to a VCS, and that is a program to manage your source code's history. And it is mostly a command line tool, but we do have some local GUIs or graphical user interface clients available for use. Today we're going to use the command line, but there are some GUI clients if you just don't want to work on the command line, and those include GitHub Desktop and then two pieces of software called Fork and Kraken. GitHub, on the other hand, is a website where you can upload a copy of your Git repository. It allows people to collaborate via Git along with some other features. So basically, this is an interactive website where people can host their repositories. I should mention there's a social component and then some other features for project management. Something to keep in mind is that you don't necessarily need to have GitHub to use Git. So you can use Git to track files on your local environment, but you do need to have Git to work with GitHub. So just keep in mind that relationship. All right, so version control system. So Git is a flavor of one version control system. There are a few others out there. And version control is the practice of tracking and managing changes to software code over time. As a project grows, version control systems help teams work faster and smarter And if a mistake is made, you can, turn back the wheel, so to speak, and compare an earlier version, and you can really check out where problems had occurred and were incorporated into your code. And then you can, fix a mistake if you need to. And it also allows you to fix mistakes while minimizing disruption. So other people can still work on a repository while you work things out. So Git is what's considered a distributed version control system. So there's two different types of version control systems. The first one is distributed and other types are centralized. And distributed means that we have a full copy on all machines. So a full copy, if you're part of a repository, a full copy is on my machine as well as your machine. And if you're using GitHub, a copy is there as well. There's some benefits to this. Other ones use what's a centralized version control system, which means that they use a centralized repository or server to host the main copy of the repository. There's a lot of benefits of using a version control system, including, of course, a complete long-term change history of every file in your repository that is controlled under Git. It also allows you to experiment through things like branching and merging. And it also allows you things like traceability and debugging. So just a note about branching and merging. We'll go over what this means in a second, but basically you can get a copy of certain files in the repository and make changes to it, experiment, create features, and then merge it to the main repository or the main branch. It also allows you to track all of your changes. So as you develop, you will start committing to the repository, and each commit has a associated change set. And if a bug is introduced to your code at some point in time, it allows you to identify where that bug happened and then fix it if necessary. All right, as I mentioned, Git is a distributed version control system. And what that means is that different users or teams maintain their own repositories instead of working from a centralized repository. What this means is that all repositories in that project are created equal. So it means that my repository is going to be just as valuable as someone else's. It's not like our main repository is going to be in a centralized server, and then we have to routinely sync up to that. Changes are stored as change sets or patches. And this is something to keep in mind, because sometimes when we talk about version control, we're like, okay, so it's going to be version 1, version 2, version 3. And that's actually not the case. What Git does, it saves the changes of those files as change sets or patches. So it tracks the changes, not the versions. And that's really where the lightweight nature of Git comes in. So it encapsulates a change set as a discrete unit, and those change sets can be exchanged between repositories. And we're really going to see this work when we start committing changes, and we can see that those changes have been given an identifier such as a hash, and we can use that change set to update other repositories. So I can commit some changes, I will create that change set, and then you can pull that change set so your repository is then updated. So the question here really is not about versions, but rather, do we have the most current change set between distributed copies? All right, some benefits of using the distributed version control means that we don't have a centralized server. It's fast, and there's some limited failure ports compared to a centralized system. And that's because if the centralized server goes down, you can't work on your project. But if you're using this distributed model, it wouldn't affect your local copy. And it also encourages independent development. So something that's really cool about Git is that it allows you a lot of flexibility and experimentation. So I can fork repositories. So if I wanted to work on a project, contribute to it, I can fork it, and then maybe submit my changes if I wanted to. And it also allows me to branch, which I mentioned earlier, will allow me to have copies and a complete copy of a working directory to do some experiments, and while the main branch is protected. All right, so let's briefly go over some Git basics. So first, I'm going to start with what is a Git repository. So Git stores information in a repository. Sometimes this is shortened to repo. You'll hear that a lot. And that repository contains your files, snapshots of your files, and references to those snapshots called heads. Your most recent commit is where your head should be in a repository. And we'll see this when we get onto the command line and doing some hands-on work. So Git repositories have a hidden .git subfolder, and you will never need to touch this, or it is unlikely that you will need to never need to touch this. So it is an invisible file, and it's created when we initialize a Git repository in a directory. So some related commands include git config, and we can config our local settings as well as our global settings. And this is the first thing that we're going to be doing when we get to the hands-on portion of today's class. We can also use git init, which initializes an empty repository or an existing repository and starts adding the version control to that folder. Okay. Getting some background noise. So if you are not muted, just go ahead and mute. Yeah, and then we also have Git status, which I like to use a lot when I'm first learning Git, to check to see where I'm at in the process of staging and committing changes to my repository. So how does it track changes? So the process of Git requires you to make changes, stage those changes, and commit them with a short commit message. And we're going to go over this sort of three-part system of making changes, staging those changes, and committing them. That really is what Git is about. And this process will be repeated over and over while development takes place. And that's really what we're going to be focusing on today, is this sort of three-part or this three-step process. So some related commands include git add, which will allow you to stage your changes, and then git commit, which allows you to push those changes to a repository. And then if we wanted to see the difference between our commits, we can use something like git diff or git diff staged. So one of the benefits of Git is the fact that we can collaborate with other people. So of course, today we're going to be using GitHub as that method of collaboration. But if we're going to collaborate with others, we need a remote repository. So a remote repository in Git is where a copy is hosted on the internet or another network. And today we're going to be using Git as that server. You can also use GitLab, or you can also set up your own server if you are so inclined. So Git associates a remote URL with a name, and your default remote is usually called your origin. And we will see the use of origin when we push our changes to GitHub today. And you can push this to this repository via SSH. So previously, GitHub allowed us to add changes to our repository from our local computers via HTTP, but now we don't have that access anymore, and they've really moved over to SSH. So previously it was HTTPS. Now they've moved solely to SSH, which is really why we had to do that before class today. And this is how we sync our repositories. And I know it can be a little bit of a pain to set up that SSH, but once that connection is established, it is much easier to push to our repositories and pull changes. All right, so perhaps you've heard about branches. What are those? So I talked a little bit about branches previously, but a branch is a place or a development branch where you can experiment and test out new features and to fix bugs potentially. By developing them in branches, so developing those changes or those features, it's not only possible to work with both of the project in parallel. So if somebody is either working on a different branch or the main branch, you can make those changes. But if work is being done on branches, you protect the main branch. And then once the code is ready, you merge it back in. So branching is a way to request a brand new working directory, so you can get a full copy of the working directory or certain files from the main branch, as well as a new staging area and project history. So sometimes it's really helpful to sort of visualize what Git is doing. In this case, this is a visualization of a Git branch. So we have our initial commit here. We see we have 4 files with version 1. And I want to make some sort of feature. And I can do that by checking out, in this case, I'm going to check out file 1 and file 3. I'm going to make those changes. I'm going to make a new commit on this branch. And I now see I have version 1.1 and version 1.1 for file 1 and 3. And once I'm satisfied with those changes, I can go ahead and merge them in back to this main branch. So we kind of see a linear trajectory of our main branch and these offshoots where development can happen in branches. So this is protected. And we see we have feature 1 here and feature 2. And feature 2 uses file 2 and 4, makes some changes, and then merges them at a different time. So this is a branch, it's being merged in, and then at a different time, another branch is created and then merged in. So that's how development can happen in parallel, where multiple things can be happening at the same time. At some point, you will be running into problems, and perhaps you've already ran into some problems. And that is just sort of the nature of coding and working with version control systems. But please don't fear, there's a lot of resources available through just community-based websites, but also GitHub, GitLab, and Atlassian has a bunch of information on how to get help when it comes to Git. There's also a Git manual, which you can access on the command line. So you just do Git help and the name of the command that you are trying to get information on. In this case, I could just do Git help push on the command line or Git bash, and it will show me the manual entry that's related to push. And I can go ahead and demonstrate that for a second. Make this a little bit bigger. Just do Git help push, and I will get the entry for push. So push is a pretty big deal with Git. So this entry is actually very long. And while this can maybe read like an insurance policy, it does have some helpful information about Git. And if you ever need to get out of here, you just do Q, and it'll Q for quit, and it'll close it out. I'm just going to close this for a second and return to my slides. Okay. All right. So one of the major features about GitHub is its 3-tree architecture. And I've kind of alluded to this earlier with thinking about this 3-step process in Git that we're going to do over and over. So for the most part, we're going to start, well, there's a few ways. This is just one example. So we're going to start with our working directory. And a lot of times this will be your local environment. I tend to work locally first and push to GitHub. Other times, and other people tend to work in GitHub first and then push down. But it doesn't really matter. Today, I'm just going to give this an example of working locally, then moving to GitHub. So a lot of times we're going to have a folder, it could be on our desktop or really wherever we keep our code. And this is going to be our working directory or project folder. And then we're going to initialize Git inside of it. So it can start tracking changes. Then we're going to do some development. So you can be working in Python, R, Perl, text files, what have you. And Git will start tracking these files. Once I have made all of the changes that I want to, then I will stage those changes and I'll do a git add and add these to the staging area. I can add all of them, all the files that I'm working on, or I can add some of them. And then I finally do a git commit, which commits them to the repository, and I will do add a message describing the changes that I've made. Okay, so this is like the very important part of Git is this 3-tree architecture of working in your working directory, making changes, staging those changes, and then pushing it to the repository. A lot of times, of course, we're going to be want to work in a collaborative environment, and that's where GitHub comes in. So in this case, we're going to have one extra step where we push those changes to origin, and that's going to be our GitHub repository. And then say if I make changes or my collaborator makes changes, I'm going to want to push them back. So I can do that by doing a git pull, and I have a new updated, newly synced repository that is fully up to date. All right, so I've said a few words about GitHub, but just a few more. GitHub is an easy way to collaborate with others on shared GitHub repositories. GitHub will host our repos for us, largely for free, and then we can sync our local copies with changes made and pushed to the shared repository. It's also a great place to explore existing repositories. So I'm sure you've probably either found a repository that was really cool, or maybe one was cited in a paper or something. And that's a place where you can view the code, but also you can get copies of it and also contribute to an open source project if you're feeling adventurous. It is the #1 site for social coding. So currently, I think there's just millions and millions of GitHub users that's just exponentially increasing. So with that said, I just want to make sure that everyone has a GitHub account. And if you don't, go ahead and make one. And if you do, let's go ahead and sign in. Okay, so hopefully everybody has signed in. This is what the GitHub landing page looks like. And then if you click on your icon, you can see your profile and your repositories. Currently, this is mine, and this is what we're going to be using today to connect to. So if everyone has logged in, just go ahead and give me a thumbs up. And then we can move on to the next portion. So we're just going to log in, and then we're going to pull up our terminal or Git bash and start working there. And I should mention that I know a lot of people on the call, this is their first time working in the command line and don't know a lot about Git. So I'm going to go slow and be mindful of everybody's learning pace. So and of course, if you have any questions throughout today, please feel free to put them into the chat. All right, seeing some thumbs up. Excellent. Okay. So now I'm going to pull up my terminal. And if you are on a Mac, you can go ahead and just search terminal. And if you are on a Windows, I believe it's Git bash in the start folder. And I'm going to increase my size. Hopefully everyone can see this on my screen. Okay. All right, we're going to go ahead and get started. So the first thing we want to do is set up our Git settings. We're going to configure our Git settings, and we're going to do that globally, which means that these are going to be associated with any of the Git repositories that we create on our computer. And if you wanted to do it locally, you can also do that. So what we're going to do is we're going to type git config -- global space user dot name, and in quotations you're going to put your name. Right, so git config -- global user dot name, and then enter your name in quotes. I'm gonna hit enter. And the next thing I want to do is config my email address. So I'm going to partially use the last code. So I'm going to, if you ever want to reuse or access a previous command that you've created on the command line, all you need to do is press the up arrow, and it'll bring it up. And then you can also see the ones I previously did. So if you ever need to get to a previous one, you can do that. It saves a little bit of time. So I'm just going to delete that part, and I'm going to go back to the dot right after user, and I'm going to change it to email, and then put in my email address. You want this email to be the one associated with your GitHub account. In this case, it's going to be my Gmail. Right? So git config -- global user dot email, and then your email in quotes. All right, can I get some thumbs up to make sure that everyone's with me? Excellent. All right. Thank you. Okay. And next we want to do a config for our branch. So this is going to tell Git that our default branch is our main. So we do that by doing git config -- global init, so init period default branch, and we have branch with a big B. So default little d, default branch, and then we'll do main. All right, so git config global init default branch main, hit enter. And those are the three configurations that we need for today. And if I wanted to look at that, I can do git config -- list, and that will give me a list of all my configurations. If you ever need to update it, so if I wanted to use a different email address, all I would need to do is rerun this prompt and it'll update it. Okay, so we can see that I've added my username, my email, and I've stipulated that my default branch is going to be main. All right, so the next thing I want to do is go ahead and start a repository. So I do that by going cd, so this means change directory, cd desktop. All right, so that means that I've changed my directory. Previously, I was on my home directory. I've changed directory to be on my desktop. And today we're going to be using our desktop. If afterwards you find that you want all of your code in your code file in your documents, you just need to cd to that directory. But today we're going to keep it on our desktop, do cd desktop, and I could do ls. And you should see everything that is on your desktop when you do that. I have a folder related to data services and then an intro to programming folder. So I have two folders on my desktop. You can just use that as a check to make sure you're in the right place. So now I want to make another folder, and we certainly could do that by just, clicking and making a new folder here with our kind of point and click versions, but we can also do it on the command line. So let's go ahead and do that. We can do make directory. So mkdir, make directory. And I'm just gonna name it mkdir space. I'm gonna let's do my first Git project. And if you're working on the command line, it really doesn't like spaces. So if you're gonna have a file name, make sure you either use dashes or underscores or what's called camel case, where you're using capital letters to differentiate between words. I tend to use the underscore, so that's what I'm gonna do, and do my first Git project. All right, then I'm gonna hit enter. And then I need to get into this folder. And what I'm gonna do is use CD again, and I can copy this to make sure I don't have any typos, and then put that directory. So I'm gonna make the directory, and then I'm gonna navigate into that directory with CD. Press enter. If I do ls, I can see it is empty, and that is good. And so I have an empty directory that I want to, make sure that I have Git access to in here. So what I do is git init. So all I need to do is git init, and that will initialize an empty Git repository in where I was. So user, my name, desktop, and that folder we're in, my first Git repository. And we can see we have that now have that invisible.git folder here. So if I do ls again, we see we have nothing here. But if I do ls-la, that will show me all of the invisible files, so the tracking files in that repository. And I do have that .git here. All right, so I'm going to give everybody a second to go ahead and create a repository, name it. You can give it any name you want, but something kind of relevant to the demo that we're doing today. And then you're going to go ahead and navigate into that folder, that empty folder, initialize Git, and then we can go from there. All right, and when you're done, you can go ahead and just give me a thumbs up. Excellent.
It looks like a few people are stuck in the chat.
I see that. So I can't link my SSH key to my account, or okay, that was a private message. And I do know that some Windows users were having some problems connecting their SSH key to the account. I have sent over, I work on a Mac, but I have sent it over to some colleagues that work on Windows at Bopst, and hopefully they can get back to me and get you all set up. And then Jay said, I am stuck at end. Any window users get stuck after -- list. I did too. So since I'm not on a Windows machine, let's get some clarifications. Or if anyone wants to clarify. And is anyone on Windows that isn't getting this error? Yes, so that is correct. So Steve said search for SSH file and open it with Notepad, and you should be able to paste it. So some people were having trouble with like the clip, which is a command on the command line that will copy your SSH key so you can paste it into GitHub. So you don't necessarily need to use the command line for that. You can just open the file and copy it. All right, so for the person that is stuck after list, I'm assuming it's this one. So were you not able to navigate to desktop and initialize Git? And if not, can you just go ahead and paste your error into the chat? Oh, and I'm actually assuming that it might be, well, we're working with Git locally, so it shouldn't, you're not actually using your SSH key right now. Okay, excellent. So it says, so Jay said, I closed the bash and skipped that step and it's working now. All right. Okay, so I'm going to continue, but I'm going to keep my eye in the chat. And if anything comes up, just let me know. All right, so I'm going to go ahead and clear my screen. And we are going to, so we've created our repository, we've initialized Git, we're now in that project, so we can start adding files. So I can do this in a number of ways. I can open up my text editor and start adding things, but efficiency wise, I can also do that on the command line. So I can do touch, and then the name of the file. So I'm just going to create, so touch creates a file, and I'm just going to do my text.txt, press enter. And if I do ls, you can now see we have a new text file here. And I can write text to that with echo. So echo greater than sign, the name of the file you want to write to, my text.txt. And I'm just going to add some text. So this is my text file, or this, let's do this is some text. I am adding my text file. You can write whatever you want, just we're gonna add some content to it and press enter. So if I use git status, I use git status a lot just to see where I'm at in my just sort of the workflow. You can see we have some untracked files. So I need to stage this and commit it, and then Git will start tracking it. But it does recognize that we have a file in our Git repository. All right. So we've created a file, we've added some text, and now we want to track it. So now we're going to do git add. And then we can do git add all. So this period means all the files in our repository, or we can just name the files. In this case, I'll just go ahead and do that and do git add my text.txt. Okay. So if I do git status again, I now have something, so it was read before because it wasn't staged, and now I have it staged here. And if you ever want to unstage anything, you just do git rm for remove -- cached, and what that will do, it'll take this file out of the staging area and move it back to your working directory. So right now, if you remember that visualization from the slides, we're now in the middle stage. We've staged our one file, and then we need to commit it. So we need to move it to that third stage. So I'm going to do git commit -m, and this is an M flag for message. And then I'm going to add a message. So add first file to project. Right? Hit enter. We can see that we've had one file changed. So because we have one file, if you had more, you would see a different number, and then one insertion. So I've added one line into that text file. All right. So if I do git status again, what I see is that I'm on my main branch. There's nothing to commit. My working tree is clean. And if that's what you want to see after you've committed something. All right. So I do want to mention, so we now have made a commit, and I can do something like git log to see the log of all of those changes. Today, we're only going to see the first one, or at least right now we're going to only see the first one because I've only made one change. So once I did that commit, I have made that commit to our repository, and Git has created this long string of numbers, and this is called a hash value. Sometimes you'll see it as a SHA-1. So it's a SHA-1 hash value. And basically what this is a checksum for each of the changes. A checksum algorithm will convert the data into a number. So the data with our changes are all encapsulated in this number. So our changes will equal this checksum. It is a 40-character hexadecimal string that we can use to we can see all of them in our log, but we can also use it to revert if we needed to, or even compare the difference between commit messages or commits. All right, so I see I'm just going to check the chat. It says, I got this warning when running add in the working copy of file txt, LF will be replaced by CRLF the next time Git touches it. What does that mean? I have no idea. Can you let me know what operating system you're using? Okay, so for Windows, I am not too sure because it's a warning. Actually, let's go ahead and when we make another, okay, so it looks like somebody else got that warning. Let's see. So if it's the same warning, we can do something like this. So I'm unfamiliar with the warning, but it's always helpful to search the error. So copy it into a browser and see what it means. So we have a few options here. We can check Stack Overflow for our error to see what happens. And a lot of times it's going to be it happened to somebody else as well. So we can review their fixes here. So LF will be replaced by CRLF the next time Git touches it. You can see that, there's some entries in Stack Overflow with hopefully some fixes or a way to troubleshoot it. Right. And sometimes these are helpful and sometimes they are not. All right. I'm going to just check some of these and we can review them. Unfortunately, I won't have time to troubleshoot everybody's sort of errors, but there are ways to navigate some of these problems. So I'm just checking a few of these answers to see if I see anything that really comes out to mind. And I should mention that we have these in Stack Overflow, you have these upvotes, which means that yes, this looks right to me or this worked for me. I like to see a little bit more than 4, but I think that just searching for the problem that you had and trying to find an answer is sometimes the best way to mitigate it. Unfortunately, sometimes these things just happen. Yep, so I see a few people got it. So I'm not too sure what to do about that other than just do a little bit of Googling and noodling with it. Because unfortunately, I am not too good at Windows. That said, I'm going to make a note of this warning and I will reach out to some folks to see if they can also fix it. Okay. So I'm going to continue and hopefully people can work it out as they search for potential answers. Once we get set up or once you get set up with, sort of navigating these issues, you will have the recording and you can refer back to it to, repeat the steps. So, if you're having trouble, it's totally fine to just sit back and watch and, learn some of the syntax so you can at least get some benefits from the class. All right. So we've now added one of our commits, and I mentioned that we do have these hash values that we can use to track our changes and to see what changes have been made, and then do some comparison. With that said, I do want to mention a few things about commit messages. So my commit message was add first file to project. Well, that is fine. It's not super descriptive, but we want to, kind of improve and have good quality commit messages added to our repository, so we know what changes have happened. So it's essential to write a single short summary. A lot of times they're going to be about 50 characters or less. For a single commit. If you have a more complete description that you want to share, you can skip a line and add a more complete description here, or you can also, there's a place to do it on GitHub as well. When we write commit messages, we actually write them in the present tense, not the past tense. So I wouldn't have said added first file. I would just say add. We want it in the first tense because we want to think of it as a label. So what is this commit? It is a fix for a bug. It's not fixed bug. Okay. So you can create your own sort of syntax or founding conventions for commits. So say if you are working with a team and you have a sort of a protocol on how you want to write those commits, it's really helpful because there's a standardized way to write them, but there's also an expectation that you're going to write complete, good commit messages. So you can include things that are helpful for you. So if it's a bug fix, you may want to include the GitHub issue number or any type of number that's related to that fix. So as I mentioned, it should be short and descriptive. It should be, it shouldn't be fixed typo. It should be closer to, I added hyphens in a project section of the HTML, something like that, which is a little bit more robust. Okay, so now that I have added a commit, let's do one more thing actually. So I've made one of the changes. So I updated the file using the command line. I can also use it, open it in the my favorite text editor. So it's the text editor of choice, and I can make some changes here as well. So I like Visual Studio Code. I've been using it for a few months now, and I like it a lot. And I can open that file here. And what's cool is that, not just Visual Studio Code, but a lot of the text editors will actually recognize it as a Git repository, which is really helpful. And it'll give you some hints and some support if you're using version control in a repository. So it says Git repositories were found in the parent folder of the workspace. Would you like to open the repository? And I'll just say yes. And I can go ahead and pick my, basically it's going to be my path to that. So I'm going to go ahead and add some more text. So this is some more text. To my file. So we can just go ahead and open that file and add an additional line of text. And I'm just going to show you how to use that, do a few things in a second. So we'll just, first things first, we will make a change, save it. So in this case, I'm just going to do Command S. I've made that change, I saved it, and I'm going to come back to my, my terminal. I'm going to clear this up a little bit. And if I do git status, I can see that it has been modified. So I want to do a git add. In this case, I'm going to do git add period here. So if I do git status, again, someone asked about restoring files in the chat. So what you would do is after you staged it, so we did that git add, which brings us to our staging area. If I wanted to pull them out of the staging area, what I would do is git restore staged. And you will see this if you run git status and you have things staged. Okay, but I don't want to unstage it. I want to go ahead and commit it. So I'll do git commit -m for my message. And I'll do add helpful text to text file. And as I mentioned, this isn't the world's greatest commit message, just because it's a demo, but we would definitely want to, put some effort into our commit messages so other people, but also your future self can find them helpful. All right, so we see we have 1 file change and 3 insertions, and that 3 is, one of it is the line of code or the line of text that I added, and the other 2 are the extra empty lines. So it even counts those as insertions, okay? So I now, if I do git log, I should have 2 commits now. So we have our most recent commit, and we can see that head is pointing to that recent one. So your head will always be pointing to the most recent commit. It's where you are sort of in space, if that's what you want to think about it. And then we have our old commit. So the commit that we used, that we committed a few minutes ago, that has now moved to our second position. So most recent, second position, which over time, this log will get even longer, okay? So if I wanted to see the difference between this commit and a previous commit, I can do something called git diff. So it'll show me the difference. So git diff, and then I will use this number. So I can use the whole thing, or I could just use some of it. So Git is smart enough to recognize that the one I'm referring to, I can just use a bit of it. I don't need to use all 40 characters. So what I would want to do is do git diff part of the most recent commit, and then whatever the older commit is here. And if I run that, we can see we have our old text and then our new text. So it'll show me the difference between what I had previously and what I have added. If I deleted something before, it would also show me that that had been removed. But in this case, it'll show me my previous line and then what I have added to it. So this comes in handy if you are reviewing commits. So if there's a lot of commits, you want to see what went wrong, or you want to do a comparison between ones just to see. This is why or how we would do that using git diff. And as I mentioned, we'll use the most recent one first and then the previous one after that. All right. So we now have created our repository, we initialized it as a Git repository, so it'll track our files. We've created a text file and we have made 2 commits on it. So now let's go ahead and push this to GitHub. So I'm going to go ahead and move over to GitHub, and I'm going to start a repository. And how we do that is just this plus sign right here. And I'll just say new repository. All right. In this case, I like to make sure that my local repository, so if I have a local repository, I want the name to match, right? So I'm just going to go ahead and copy the file name over, and it's going to be my first Git project. I'm going to go ahead and keep it as public. And I'm not going to press anything else. I want the default. And that is because we already have an existing repository. I don't want to add anything. I don't want to add a README file at this point. I don't want to choose a license. So don't press any of that. We're just going to leave it as the default. And I'm going to go ahead and create my repository. Okay. So this is what you're going to see. So we have a few options here. We can create a new repository on the command line, but these actually should be pretty familiar. We've already done git init and did a commit. So we don't need any of that. What we want to do is push an existing repository, so the second set of instructions. So I'm going to use this git remote add origin. So remember, if we want to collaborate with people, if we want to use GitHub, we're going to have to push it to our remote or in our origin, and this refers to the origin on GitHub. Okay. So I'm going to go ahead and copy this first line. I'm going to go back to my terminal. So I'm going to go ahead and clear this up. add this. Okay, hit enter. Git branch main, so that second one. And then the third one. Okay. So sometimes you will get a prompt that you need to add your GitHub credentials, and you can go ahead and add that. But if I go back to GitHub and I refresh, I now see my text here. So the text that I was working at locally has now been connected to GitHub and pushed there. So and now a copy lives on my GitHub repository. All right, and I will go ahead and give everyone a few minutes to go ahead and do that. And then we're going to make some changes on GitHub and then pull it back down. And something that I should mention is that actually, no, I'm sorry. When we want to clone it, so if we have an existing repository, we're always going to want to use this SSH, and that'll come up in a second. I was just getting a little ahead of myself. All right, so I'm going to go ahead and ask for some thumbs up as a visual cue for me. Excellent. All right, cool. All right. All right, excellent. I'm seeing a bunch of thumbs up, so I'm going to go ahead and move on. And I do want to mention that all of the commands, everything that we have done in class are in the slide deck. So if you ever need to repeat them, you'll have that resource. And I'll send the slide deck out with the recording later this afternoon. All right, so now we see that we've connected what we had locally to our GitHub account. And what I can do is make changes. So this can kind of be a stand-on on changes that I make in the browser, or it could also, be changes that someone else pushed to the repository on their end. So let's just say that we're going to update this. I can update a text file here, so I can update README files and text files on GitHub directly. And I can edit it here. So I'm going to add one more line. So I added this line using the GitHub browser. So I've added a bit of text. I can go ahead and make a commit here. So this is basically the same thing that we did on the command line. We're going to add that commit message. If we needed an optional extended description, I could add it here, and then we're going to commit. So this is, kind of a point and click version of writing that commit message and then committing it directly. So I'm just going to do update text file for demo. All right. Now we can see that it has changed on the browser. And now if we think about it, our GitHub repository on the internet is more up to date than our local repository. And we're going to want to do something about that. And that means that we're going to want to pull those changes back to our local environment. And we do that doing a git pull origin main. So we're going to do a git pull on our origin, which is our repository on GitHub, and main because we're on our main branch. Okay. So now we can see that it has updated. So we can see that we've had some our updatings, and then we have our text files with 2 insertions. Okay. So if I go back to my text editor, and I open that file, we can see that it is that third. You can open it here actually, a little bit more visual. I added this line using the GitHub browser, and now that it is, now we made that change in our remote and we pushed it down, or excuse me, we pulled it down. All right. Now, that is the workflow for working locally, starting locally, initializing a Git repository, making those changes, staging them, committing them, and then that last step of pushing them to GitHub. Sometimes people would want to, kind of change that, and I can show you how to, excuse me, start on GitHub and then move locally. And we can do that. And this is probably the, I have a few things that I want to show you, but this is the last thing we'll do on the command line, and then we'll return to the slides, and I have a few resources for you. All right, so if I go back to my repository, I can just start a repository. So I'm going to start a new repository. I can name it anything. GitHub, just allows you to, or creates like just funny names here. So Crispy Computing Machine, I can just go ahead and choose that name just for fun. And I can, because we're starting on GitHub, I don't have an existing repository locally. I can go ahead and add a README file, and I can choose a license if I want to. There's, a lot of licenses that you can choose from based on your repository and sort of the how permissive you would want that license to be. In this case, I'm just going to leave it empty, but I've created one. I've used the funny name. I'm going to add a README file. I'm going to go ahead and create that repository. All right, so I've created it. I have a README file. Now I want to bring it back to my local machine, and I'm going to do that. I'm going to go ahead and clear up my screen. And I'm going to do CD because I want to get back to my home directory. You can see that. And then I'm going to navigate back to my desktop. All right. So now I am on my desktop. What I want to do is clone this repository to my desktop. And I do that by going to code. So you get this big green button. I can code it, I can clone it. You can see that it automatically goes to SSH now. If it's on HTTPS, you don't want to use that one. You want to use SSH. I'm going to go ahead and copy it. And I just do git clone and that link. Okay. I'm going to press enter. We now see that it has been cloned, or at least it, the output looks like it has been cloned, and I can double check. I'm working on 2 screens, and so you can't see that a new file has appeared on my desktop, but if I do ls, you can see it in this list. I have Crispy Computing Machine. Okay. So I can go ahead and CD to this folder. And this is already a Git repository because we started on GitHub. And I can go ahead and update a file. So where did I find that link? So this link, so I created the repository on GitHub. If you go to code and hit this green button, you will see the SSH link. Okay, and you don't want to use the HTTPS link, you want to use the SSH link. Go ahead and copy it. And you're going to want to do git clone and then that link. Okay. All right. So now I'm in that repository. If I do ls, we can see that README file that we created on GitHub. So it's the one over here. And I can update that if I want to, so I can, open my Visual Studio Code. Oh, interesting. Okay. So it may be worth mentioning that Bash doesn't always like Control V. I'm assuming that's Control Copy or Control Paste and such. So I will keep that in mind. So it may mean that you need to just go ahead and write it out. So instead of copying, pasting, just carefully write it out. And if you get an error, it may be because there might be a small typo or something.
You can probably do right click and choose paste, and I think that should work if Control V is not working for you.
For Windows?
Yeah.
Okay. All right, so if I go to desktop, you can see we have Crispy Computing Machine and that README file. I'm going to go ahead and open it. Right, and then I can, so this is a markdown file, and you can add markdown headers with these, the hashtags. So this is going to be a heading 2. Just say welcome to my repo for my Git workshop. Okay. Welcome. I hope you are learning a lot. I'm gonna go ahead and hit save, Command S. And then I'm gonna do git add that readme.md. And then commit that change with a message, update readme file for class. Okay, I've now made those changes, I've staged them, and then I committed them. And then we're going to do one extra step because I want to push those changes to my GitHub repository that we created. So git push origin main. All right. And if I go back to GitHub and I refresh my page, we now see those changes happen. So I am now going to hand the reins over to you to make some changes to the GitHub repository that we cloned. So go ahead and make a change. You can update that README file, stage those changes, commit them, and then push to GitHub. And if you're feeling adventurous, you can use something like git diff to compare the changes that you made. So I'm just going to give everyone a few minutes to do that. And then we will reconvene around, let's say 1:15, and then I will wrap up, and I have some additional slides and some additional resources that will help you, move on, because, Git takes time. And so I'll give you some resources to learn even more. So I will go ahead and mute. But if you have any questions, just let me know. Okay, so hopefully everyone has had a chance to either, at least get some partially way. Hopefully everyone was able to make changes to the repository, suggest changes, commit them, and then push them to GitHub. So I'm going to go ahead and wrap up. I should mention, if you did have any trouble, this class is not where communication with me ends. So if you continue to have trouble or any trouble, go ahead and email me. I'm happy to answer questions and help out. With that said, I'm going to go ahead and clear this and close it out, close this out, and I'm going to return to the slides to go ahead and wrap up class. All right. So as I mentioned, I do have some additional content in my slides. That includes how to delete files. So a lot of times with Git, you can also recognize or at least acknowledge in your repository that something has been deleted. So it becomes part of the record and the history of a project. And you can do that with these steps. If you ever need to restore a file, you can do that with this step. So you can either restore it fully if it's been deleted, or you can also use restore to take something out of staging. And then also you can use Git to rename and move files. So all of this are in the slides that I'm going to send out after class. But I just want to wrap up with a few other things. At some point, you may see some files that you don't want to go into your repository. So this could be, if you're on a Mac, the ds_store, which is an invisible file that a lot of times will come up on Macs. Sometimes actually VS Code creates one, or R creates an R history file. Sometimes these aren't relevant to the repository that we want to share on GitHub. So you can create a git ignore file, and then you can add the file names to that list, and then commit the list to your repository, and then Git will start ignoring them, and they won't be part of your repository. If you have any questions about it, you can go to the github.com, the git ignore page, which will tell you a little bit more about it. But there's also a lot of templates that you can use and add those to your repository. Something to think about is that as you develop and use Git, especially if you're working with other folks on a project, you may eventually run into what's called a merge conflict. And a merge conflict means that, say that you are working on, that main branch, and then you want to create your own branch for a particular project or for a particular feature over here, and then someone else wants to do the same thing. They've made a merge, and then you made a merge at some other point in time, and there's some conflict. And this happens because Git doesn't know how to basically interpret the changes that have made. Maybe they have edited the same line that you have, or deleted a file that you're still using. It'll create a merge conflict. So there's some ways to navigate that. And basically what you need to do is just tell Git how to interpret it and sort of what's the right answer between those two or more options. So merge conflict happens when an event takes place that Git is unable to automatically resolve automatically. It can happen for a number of reasons, including differences in the main branch and the development branch that are potentially unexpected. And there's other types of sort of competing commits. For example, they can happen when people make different changes to the same line of the file, or when, as I mentioned earlier, a person edits a file that's already been deleted, things of that nature. You will need to decide how those changes will be integrated, and Visual Code Studio can help you make those selections and compare the incoming branch and main branch. So they may happen, don't panic, there are ways to resolve those merge conflicts. Today is probably a crash course for a lot of people, and we're really just scratching the surface when it comes to learning Git. There's a lot more to learn. So I put together a list of resources. There's a really good Git cheat sheet, it's basically a quick reference guide to some of the most common commands. There's also a link for resolving merge conflicts, some additional skill buildings, and trainings from GitHub. Actually, the GitHub trainings are very, very good. And then some other free ebooks that are available on the internet, and some other just sort of reference guides for you. And that is it. I want to thank you all. Today was our pilot of this Git class, so I really appreciate your time and attention. Okay, thanks a bunch. I'm going to go ahead and stop the recording.